Alright, this is the 1988 practice test, and one thing you'll notice is that the 1988 test is different in a lot of respects from the more recent test, the 1998, 2003, 2008. This test focuses more on skill work, whereas the more recent tests focus on the applications, but it's good to get these skills practiced. Please take time this week over spring break to do your memorization of all your trig derivatives, trig integrals, review the concepts that you need to brush up on. Alright, so let's just jump in here. Number one, we're going to find the derivative by the product rule, and the answer is letter C. When you find that, you'll have the first derivative of the second plus the second times the derivative of the first. You'll need to factor out the x e to the x, and that'll leave you with x squared plus 2, which is letter C. Number two, they do not ask us to find domains of functions anymore on the AP test, so we're not going to worry about that problem. Number three, we have the velocity of a particle. We're trying to find out how far does the particle move. So they're really asking us for the total distance. Now in this case, e to the t, all of the area is positive, so it doesn't really matter whether we think about area being positive or not, but it is, so we don't have to do anything special to force any negative area to be positive. When we find the antiderivative of e to the t, we get e to the t, and when we evaluate it from 0 to 2, we get e squared minus e to the 0, and of course e to the 0 is 1, so e squared minus 1, which is letter A. Problem number 4, they give us the graph they give us an original function, and they want to know when the graph is concave downward, so we need the second derivative. Now I'm going to rewrite this as negative 5 times x minus 2, and when I find the first derivative, I'm going to use the chain rule. That would be to the negative 1 power. So when I use the chain rule, I'll get positive 5 to the x minus 2 to the negative 2, technically times 1, because the derivative of the inside is 1. Second derivative, I'm going to use the chain rule again, and I'll get negative 10 times x minus 2 to the negative 3, which is the same thing as negative 10 over x minus 2 to the positive 3. The only critical number that we have here is 2, and I'm going to make a second derivative number line. When I choose a number larger than 2, I'll get a negative outcome, so I'm concave down. If I choose a number smaller than 2, I'll get a positive outcome, so I'm concave up. We were looking in number 4 for concave down, so that would be x is greater than 2, so that would be e. Number 5 is very straightforward. If you've memorized your trig integrals, who has a derivative of secant squared, and that would be tangent x plus c. Problem number 6, we're finding the derivative. We're going to do the quotient rule here, so we'll have down d up minus up d down, which is 1 over down down, which is x squared. This will give me 1 minus ln of x over x squared, which is letter C. 6 is... Ooh, I almost got caught up. Letter D, I had the right work and almost the wrong answer. Number 7 is a u sub problem. U is 3x squared plus 5. du is 6x dx. We don't need the 6. So we're going to have 1/6 of u to the negative 1/2 power, bringing that up. That will give me 1/6 of u to the positive 1/2, increase the power by 1, divide by that power. Dividing by 1/2 is times 2, so that's going to be 1/3 of u to the 1/2 power. And of course I'm going to put this back in place of u, and the answer is letter D. Problem number 8, we're looking for, we have an original function. So the first thing they tell us is the first derivative is positive, so that tells me the original function is increasing, so that would be this region. The second thing they tell me is that the second derivative is negative, so I'm looking for concave down, and this is concave up, this region is concave down, so the answer is the region from B to C, which is number 2, which is B only. Number 9, we're going to find the derivative by implicit differentiation, and then we're going to evaluate it at 1, 1. So if we find the derivative of x is 1, Here we're going to have the product rule, first derivative second plus second derivative first minus 2y dy dx is equal to 0. I'm going to get the dy dx's on one side and factor out dy dx. That will leave me with 2x minus 2y. I'm going to get all the non-dy dx's on the other side. That would give me negative 2x minus 2y. When I divide both sides, I'll get dy dx equal to negative 2x minus 2y over 2x minus 2y. Now I'm going to substitute 1, 1 in place of x and y. And I can see in the denominator right away, if I substitute 1 and 1, I'll get a 0 in the denominator, and I can't divide by 0, so the answer is non-existent. In number 10, they're asking me to find an antiderivative, and they've already told me the answer is 18. K I'm going to treat as a constant, so when I find the antiderivative, I will get 2. When I find the antiderivative of this term, I'll get 2kx squared over 2, so that would just give me kx squared. The derivative of the second term is x cubed over 3. We're evaluating that from 0 to k, and the answer is supposed to be 18. When I substitute k, that will give me k times k squared, which is k cubed, minus k cubed over 3. Now when I substitute 0 into both of these, I'm going to get 0. So that will be equal to 18. Get a common denominator, so I'll have 3k cubed minus k cubed over 3 equal to 18. Combine like terms, and that'll give me 2k cubed. Multiply both sides by 3, that'll give me 54. Divide both sides by 2, that'll give me 27. Take the cube root of both sides, that'll give me 3. So the answer is C. Number 11, write the equation of a line tangent to a curve at a point. Now the first thing I notice is that every single one of these equations has a different slope. So if I can find the slope, I can find the equation without having to do all the work. I need a slope generator, so the derivative by the product rule will be the first function times the derivative of the second, 1 minus 2x, squared times the derivative of the inside, which is negative 2, plus the second function, which is 1 minus 2x, cubed times the derivative of the first. Just a teeny bit of cleaning here, that'll give me negative 6x times 1 minus 2x quantity squared, plus 1 minus 2x to the third power, and now I'm substituting the x value of 1. That'll give me negative 6 times the inside would be negative 1, squared would be positive 1. Negative 1 in this term right here will give me an output of negative 1. So I get negative 6 minus 1, which is negative 7, and the only line that has a slope of negative 7 is A. Alright, moving on to number 12. Simple, find the derivative of sine, cosine, evaluate it at pi over 3, and the cosine of pi over 3 is 1/2. Number 13, they tell me I have a continuous derivative, and that I'm trying to find the antiderivative from 0 to c. This is kind of a symbolic problem. In other words, they're saying how do you evaluate a definite integral? Well, when you evaluate the definite integral of f prime, you would get the original function f of x back, evaluated from 0 to c, so that would be f of the upper bound minus f of the lower bound, which is letter A. Number 14 is a u sub problem. U is equal to the what's under the radical, 1 plus sine theta du is equal to the cosine theta. So when I make my substitution, that will give me the integral of u to the negative 1/2 power du. So that would be, when I change it back, that would be the integral from, well, let's go ahead and integrate it. That would be u to the 1/2 divided by 1/2, which is 2. So that's going to give me 2 square root of 1 plus sine theta evaluated from 0 to pi over 2. So that would give me 2. The sine of pi over 2 is 1 plus 1 is 2. minus 2, substituting in 0. Sine of 0 is 0, so that would give me square root of 1, which is 1. So I get 2 root 2 minus 2. I can take out a 2, and that would give me root 2 minus 1, which number 14 is letter D. Number 15, a simple derivative. I'm going to rewrite this as 2x to the 1/2 power. So the derivative would be 1/2 2x to the negative 1 times the derivative of the inside of 2. I'm going to evaluate it at 2. So that would give me 1/2 of 4 to the negative 1/2 times 2. That would be 1/2 of 1/2 times 2, which is 1/4 times 2, which is 1/2, which is B. Now again, don't forget in this term right here you have a negative power, so it's going to go to the denominator, and then I'm going to take the square root. Number 16, we're looking at a particle moving for t greater than 0. We want the particle at rest, so we know that that means velocity has to be equal to 0. So I'm going to find the velocity function here. By the derivative is 3t squared minus 6t minus 9, set it equal to 0. I'm going to factor out a 3 and divide it on both sides. That'll give me t squared minus 2t minus 3 equals 0. t, 3, 1 minus plus, so t equals 3, t equals negative 1. That's to the left of 0, so the only answer is t equal to 3, which is C. Number 17, if you try to do u sub, you're going to get stuck. You need to square the binomial, so you'll get 9x squared minus 12x plus 4, evaluated from 0 to 1. So you get 9x cubed over 3, which is 3x cubed, minus 12x squared over 2, which is 6x squared, plus 4x. Substitute in 1, and that'll be the answer, because when you substitute in 0, you get 0. So the answer for 17 is letter D. When you do your substitution, you should get 1. Problem number 18, we're finding the second derivative. So we're going to use the chain rule here. The first derivative, the derivative of cosine, is negative sine, so I get negative 2 sine of the angle times the derivative of the angle. The derivative of the angle here is 1/2. Half of negative 2, so I get negative, so I get negative sine over x of x over 2 as my first derivative. Second derivative, derivative of sine is cosine, so I get negative cosine of the angle times the derivative of the angle, so that would be 1/2 cosine, negative 1/2 cosine of x over 2. So in number 18, that would give me letter E. Number 19 is another u sub problem. U is equal to x squared plus 1. du is equal to 2x dx, and I don't need the 2. So I'll have 1/2 the integration of 1 over u du. And this time I'm going to go ahead and change my u bounds into, my x bounds into u bounds. 2 squared is 4 plus 1 is 5. 3 squared is 9 plus 1 is 10. The antiderivative of 1 over u is ln of the absolute value of u, evaluated from 5 to 10. So that would be 1/2 ln of 10 minus ln of 5. By log properties, that's ln of 10 over 5, which is 1/2 ln of 2, which for number 19 is letter B. Number 20, I have a polynomial function. Now, polynomial function means the degree is greater than 2. So a polynomial function is like x cubed plus 3x plus 4, x to the 4th minus 5x, etc. Now, the reason they need to tell you it's polynomial is that you have to understand that they're telling you that the function is continuous and differentiable. There are endpoints where f of a is equal to f of b. They have the same y of a, so it's feeling very much like Rolle's theorem because it meets all the criteria. Now remember, Rolle's theorem guarantees that somewhere the derivative has to be 0, which is number 2, which is letter C. 21, we're finding area enclosed between two curves. Now, I'm not going to take the time to graph that, and probably you would not want to graph it either. So the first thing I'm going to do is find the points of intersection so I can get my bounds. X equal to x squared minus 3x plus 3. 0 is equal to x squared minus 4x plus 3. Factoring that, I get x and 3 and 1 and minus and minus. So I get x equal to 3, x equal to 1. So I know that I have an integral from 1 to 3. Now, I need the top curve and the bottom curve. I'm going to choose a number between 3 and 1, and I'm going to plug it into each function and see which gives me a larger output. If I plug 2 into this function, then the output is a 2. If I plug 2 into the parabola function, I'll get an output of 1. So the line is actually on top. So I have the top function minus parentheses, the whole thing, plus 3 dx. If you distribute the negative, combine like terms, find the antiderivative, and then sub and solve, you will get a final answer of C 4/3. And you could confirm that with your calculator, even though this is not a calculator test. Number 22 is a log equation to solve, and they don't ask us to simply do pre-calculus questions anymore on the AP test. Number 23 is an old concept that they don't ask us anymore called L'Hopital's rule. It's a BC topic now, so we won't get into that. 24, when I find the derivative of x to the ln of x, we have a formula for finding the derivative of things like 2 to the x. When the base is constant, we have a formula for that. However, this problem does not have a base that's a fixed number. It has a variable. So this is logarithmic differentiation. So basically we have the function y is equal to x to the ln of x. And our problem is we have a power up there that we need to get down, and the only way we can do that is to take the ln of both sides. So I'm going to take the ln of the left-hand side and I get y. And on the right-hand side, I'm going to take the ln of what was already there, which is x ln of x. So what you see in blue was the function that I'm taking the ln of. Alright, now on the left-hand side, everything stays the same. I get ln of y, but on the right-hand side, I'm going to use a log property to bring this power down, and that will give me ln of x times the ln of x. Now this ln of x right here is what's left over from this part right here. So I'm bringing this ln of x in front, and this is the ln of x that's left over. So that's the ln of y equal to the ln of x quantity squared. And then when I take the derivative of ln of y, I get 1 over y, that's an error, 1 over y dy dx. On the right hand side, by the chain rule, I get 2 ln of x to the first power times the derivative of the ln of x, which is 1 over x. So I just went ahead and put it in the bottom. And then the last step is to get dy dx by itself. So I have 2 ln of x. I would multiply both sides by y, and the original y was x raised to the ln of x. So that knocks out this one, that knocks out this one and this one. So the answer is letter C. Number 25, we're finding the derivative of a definite integral. So take out the t, put in the new function, and multiply by the derivative of the new function. So number 25 is B. 26, we're finding an antiderivative. All right, this is an old concept. It is the integration by parts, which we no longer have to do in the AB class. So you may ignore number 26. We have a function, and they're asking us some things about it. So first of all, at x equal to 3, let's see if the function is defined. When we put in 3, we output 9, and when we put in 3, we output 9. So this is open, and this is closed. So let me make sure I did that right. Yeah. So is f of 3 defined? Yes, it is. Is the function continuous? Well, a parabola by itself is continuous, and a line by itself is continuous. So graphically speaking, we have the point 39, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's closed. Remember, this was open and then this closed it. On the left-hand side, we have a parabola, so it would be something like that. And then on the right-hand side, we have a line with a positive slope, so maybe something like that. So the graph is continuous, but it is not differentiable because there's a sharp turn there, so there's our answer. 28, we're finding the antiderivative of an absolute value function. This is a good review. When you're doing absolute value, you want to do it by a graph and you want to collect area. The first thing you need to do is to figure out the vertex of the absolute value. So you set the inside equal to 0 and you get x equal to 3. So 1, 2, 3, that's the vertex of the absolute value. Now you want to find the y value of 4, so I put 4 in. 4 minus 3 is 1, and the absolute value of 1 is 1. You want to substitute in 1. 1 minus 3 is negative 2, and the absolute value of negative 2 is positive 2, so you get 1, 2. So now you're literally simply finding the area of two triangles. So this is 2 by 2. 2 times 2 is 4. Half of 2 is 2. Here you have 1 by 1, so you get a half. So you get 4 halves, which is 2, plus 1 half, which gives you a total of 5 halves. So number 28 is C. 29, that is the definition of the derivative. So what they're really asking you to find out here is what is the derivative of tangent of 3x. It's just a sneaky way of saying find the derivative of tangent 3x. Chain rule, the derivative of tangent is secant squared of the angle times the derivative of the angle. So number 29, we get letter B. Number 30, we're looking for a region in the first quadrant that's enclosed by y equal to e to the 2x. Now e to the 2x is an easy graph. It just grows a little bit faster than e to the x. And then we have x equal to 1. Okay, and they want us to rotate. Oh, here we go. Rotate, revolve about the y-axis. Now, this question right here, you're not going to find I'm going to do the problem, but you won't find the answer because there is an alternate way of finding this. You'll notice that a lot of the answers are in terms of x. We don't it's called the shell method. We don't teach it anymore, but I'm still going to go ahead and do this problem just for practice, even though we won't find the answer over here, because their answer will be in terms of x. So the region that we're revolving is this right here that I've highlighted. We're revolving it around the y-axis. So this is going to be a solid. So we're going to, since we're revolving, remember we have pi r squared, the area of a circle. We're making circles here. There is no hole. This is going to be a solid region because the region is flush to the x-axis. The lower bound is going to be 0, a y value of 0, and the upper bound is going to be the y value when x is 1, which is e to the e squared, when I substitute 1 in place of that. So lower bound to upper bound. Now I need my radius, which is the distance from the axis of revolution to the curve, and the distance from the axis of revolution is going to be 1 squared. All right, actually, in looking back at this is going to be a mess for us to do in any way, shape, or form, because the big R from in this region is this distance, but when you get to here, then big R is going to be the difference between those two. So really, I knew something was going on here. They would not ask you this on the AP test, but I still want to explain it to you. The first region that we're looking at goes from 0 to 1. pi out front, and the radius is 1 squared dy. So what that takes care of is this region right here. Okay, so then I would have to add that to, I'm going to change colors now. I'll go with, I guess, a green or something. Now I need to find this region in here. So I'm still going to have pi because I'm revolving. I'm going to start where I left off at a y value of 1 and an upper value of e squared. But now the radius is going to be the right curve, which is 1 minus the left curve. So it's y equal e to the 2x. We need to solve for x. So that would be ln of y equal to ln of e to the 2x. Well, that cancels out. So I get ln of y equal to 2x. So x is equal to the ln of y over 2 squared dy. And you can see that that answer is not over there because, like I said, this problem was designed for the shell method, which is a method that we don't use anymore. But that's how you would do this problem. It's not the worst problem in the world, but it is kind of a pain in the butt. All right, number 31, we're finding the derivative of an inverse. Now, you do have a formula for finding the derivative of an inverse, and most of the derivatives of inverses that we've looked at have been when we are finding the derivative of an inverse at a specific value, but this just wants the actual function. So here's how I think I would do this problem. Number one, I would actually find the inverse function. Now, remember, inverse functions, you get y equal to x over x plus 1, and for an inverse, the x's and y's switch places, so you get x equal to y over y plus 1. Remember, inverse functions, you switch the x and y. And then I want the derivative of that, so I'm just simply going to take the derivative on both sides, and the derivative of x is 1. The derivative of y would be d, oops, we got to do the quotient rule there. So we're going to have down d up, which is dy dx, minus up d down, which will be another dy dx, over down down. And that will give me, all right, I'm actually running out of time to do this problem, so I'm going to stop this video here, and then I'll make a second video that picks up the test at, go to the next video for the next problem, and then I'll finish that set.